Hello students, welcome to Solochem Lab. We're about to solve a UTME problem 2022. The problem on the board is the products of the electrolysis of dilute sodium hydroxide using platinum electrodes are, some options are given to us. To solve this problem, you need to underline this word, dilute sodium hydroxide. Everybody who is offering chemistry at this level knows that the chemical formula of sodium hydroxide is NaOH. Is that clear? NaOH. And if you are told dilute, it means a solution of sodium hydroxide has been made. A solution of sodium hydroxide has been prepared. In your SS1, when you were studying acids, bases, and salts, you were taught that a solution is a mixture, a thorough mixture of two components, two or more components. Usually the solid component is called the solute, and then the liquid component is called the solvent. So sodium hydroxide at room temperature is in solid form, so that is the solute. Then water, H2O, usually at room temperature, you know water is in liquid form, so that becomes the solvent. Is that clear? So when I prepare a solution of sodium hydroxide, NaOH, in aqueous form, and the word dilute, that adjective dilute, is trying to explain that the solution has more water and a little of the NaOH. More water, a little of the NaOH. When a solution contains more of the solvent and less of the solute, that solution is described as a dilute solution. Do you understand? Another thing we are going to clarify is this word here, platinum electrodes. Platinum electrodes. In electrolysis, whenever we use platinum as an electrode, what happens is that the electrode does not take part in the electrolytic process. I said platinum electrodes do not take part in the electrolytic process. They do not influence the product that we obtain. Do you know why? Because they do not interact, they do not interfere with the reaction. So we describe platinum electrode as inert, as an inert electrode. Inert means it doesn't take part in the electrolytic process. It doesn't influence the products. Is that clear? Those are the things you have to take note of whenever you are solving problems on electrolysis. It does not take part in the electrolytic process. It does not influence the products. Okay. Then another thing you are going to find out is this. When we have sodium hydroxide solution, what are the ions that are going to be produced? Let's get down to that again. NaOH in aqueous form is going to give us sodium ions and OH ions. Look at the equation. Do you understand this ionization equation? Sodium hydroxide, which is what they have given to us here to carry out its electrolysis, is going to give us sodium ions and hydroxide ions. Is that clear? Again, did you notice that to produce a solution, the solvent water is used. Do you understand? So the solution contains water. These ions, are they the only ions we are going to have from sodium hydroxide solution? No. Water itself dissociates into ions and give us hydrogen ions, that's hydrogen cation, and OH minus hydroxide cation. Is that clear? Okay. These two cations, the sodium ions and the hydrogen ions, will migrate to a particular electrode. While these two, you see they are just the same now, no difference. They will migrate to another electrode. To which electrodes will these ones migrate? And to which electrodes will these ones migrate? That could be another jam question. So I'm going to sketch a diagram. Are you through with understanding these ones on the board? Because I'm going to wipe them off and sketch a diagram of an electrolytic cell so that I can explain to you the electrode to which the sodium cation and the hydrogen cations will migrate before the electrolytic process starts. I'm going to wipe off these ones here so that I can sketch a diagram of electrolytic cell. Electrolytic cell is an arrangement of two electrodes in an electrolyte, and it can be used to bring about a chemical change. I have a container. Do you understand what I'm trying to indicate here with the dots? That's the electrolyte, a suitable electrolyte. The two plates dipped in the electrolyte, do you remember what they are? They are the electrodes. Look at the sketching I have here. At this point, one stroke is longer than the other. Is that a mistake? Should two of them be of the same height? If two of them are the same height, it's not representing an electrochemical cell again. This is an electrochemical cell, and that's what is represented by this. One has to be longer than the other. If you mistakenly make two of them to be of the same height, you are now referring to capacitor in your physics. Okay, look at this dry cell here that I'm holding. Check very well. You see there's a place that is marked positive. This positive refers to this longer terminal here. That's the cathode. The cathode of electrochemical cell. And then look at this area that has minus written on it. Minus. This refers to this shorter terminal, this shorter line. And that is the anode. I'm going to write. This is the negative terminal is the anode, while the positive terminal is the cathode of the electrochemical cell. Cathode. What does this minus mean? Which component, which subatomic particle has a negative charge? Electrons, am I right? So if you have minus here, it means there are excess electrons here. And so they move this way. When they get here, they make this electrode to become negatively charged. Do you understand? And then this direction. So this electrode here that you've connected to this cathode, this positively charged terminal, has a positive sign, positive charge. But take note, in the naming of the whole electrolytic cell, this terminal that is negatively charged takes this name here. And then this terminal that is positively charged takes this name here. I hope that will not confuse you. In the electrolytic cell, the negatively charged electrode is called cathode, while the positively charged electrode is called the anode in the electrolytic cell, the whole of this. But for this electrochemical cell, this dry cell I'm holding here, the part of it that is positively charged, which is indicated by the longer line here, is called cathode, and the shorter one is called anode. I hope that this swap of names will not confuse you, JAMB students. Let it not confuse you. Just take note of it. I'll give you a minute to process the information before we move on. In the electrolytic cell, the negatively charged electrode is called cathode. The positively charged electrode is called anode. But in this dry cell, this electrochemical cell that is giving us current, that's supplying DC, the positive terminal is called cathode, and then the negative terminal is called anode. Take that and let it not confuse you. It is from there that we move on. Do you remember that when we ionized the sodium hydroxide, NaOH, when we ionized it, we obtained sodium ions and OH ions? Do you still remember? To which electrode will the sodium ions migrate? Also, do not forget that when we ionized water, H2O, we obtained hydrogen ions and hydroxide ions. What charge do sodium ions have? Do you see positive charge? Because they are metallic ions. Then hydrogen ions also have positive charge. Do you understand? In your basic physics, what were you taught about like charges and unlike charges in your basic physics? What were you taught? Do like charges attract or repel? Like charges repel. That is, this positive charge here, this positive charge here, when they come to the anode, they will be repelled. So they will be attracted to where? The cathode. Is that clear? So sodium ions and hydrogen ions will be attracted to the cathode of the electrolytic cell, because the cathode of the electrolytic cell has a negative charge. Opposite charges attract. Is that clear to you? Then the hydroxide ions, which are negatively charged, will they be attracted to the same charge, the cathode, which has negative charge, as they do? No. They will be attracted to the anode of the electrolytic cell. This is where they will become discharged. Take your time, look at the diagram, and we'll continue from there. When the sodium ions and the hydrogen ions become attracted to the cathode of the electrolytic cell, which of the two will become preferentially discharged? Will the sodium ions become preferentially discharged, or will the hydrogen ions become preferentially discharged? To answer that question, it brings us to one of the three factors that control the preferential discharge of ions. And one of them is the relative position of the ions in what we call the electrochemical series. Let's just put it simple. Sodium ions and hydrogen ions. Sodium and hydrogen, which one is more electropositive? It is sodium. So sodium will remain in solution. It will persist in this solution and then tell hydrogen to go out first. Go out first. So at this cathode, hydrogen will become preferentially discharged because it is less electropositive than sodium. Sodium will remain in the solution and then tell hydrogen, go out first, become discharged first. Do you understand? And how will that happen? What does this hydrogen ion not have enough? It does not have electrons enough. And what does cathode have in excess? If it is negatively charged, it means it has electrons in excess. So at the cathode, electrons will be given to each hydrogen ions and it will become discharged as hydrogen atom. It seems you're not seeing what I explained very well. So let me explain it again. At the cathode, which is negatively charged, hydrogen ions which migrate to that place along with sodium, each hydrogen ion will receive electron, and when it receives electron, it becomes discharged as neutral hydrogen atom. Remember, hydrogen does not exist alone. One atom of hydrogen cannot exist alone, so it's going to combine covalently with another atom of hydrogen to become discharged as a diatomic hydrogen gas. Do you remember when we did bonding? So between these two hydrogen atoms, now you have a single covalent bond. That is how hydrogen becomes discharged at the cathode. So let's come here and check. Hydrogen will become discharged. Sodium will never be discharged from a dilute solution of sodium hydroxide. I'm going to say it again. Sodium will never be discharged from a dilute solution of sodium hydroxide. Do you know why? Sodium is very, very electropositive, highly electropositive than hydrogen. So in the presence of hydrogen, sodium will never become discharged until the last atom, until the last ion of hydrogen must have been discharged. Do you understand? So this explanation makes this option A not correct, because there it says sodium metal becomes discharged, and that can never happen. So option A is off. Is that clear? Water can never be discharged in this process. Water can never be discharged. So the two options that contain water are off. Is that clear? We are left with this that says hydrogen becomes discharged at the cathode and then oxygen gases. Let's see oxygen gas. Let's see what happens at the anode. At the anode, I'm going to wipe up this so that I can explain what happens at the anode. At the anode, OH ions. Remember, anode is positively charged. So each OH ion is going to lose its extra electron. It's going to drop it because anode is deficient in electrons. It wants more electrons. Do you understand what I've explained? This has excess electron. It's going to drop it and becomes neutral. Then again, the OH is going to combine with another OH to become H2O and oxygen. Do you understand? Then a single oxygen atom, can it exist alone? No. So one oxygen atom is going to combine covalently with another oxygen atom to give us O2, a diatomic gas. Do you remember when we explained bonding? We said that O2 has a double covalent bond between it. So option B is the correct option to this question. Do you have any question? Don't fail to drop the question at the comment section of this video so that in our subsequent classes we will look at those questions. Remember, at Scholochem Lab, chemistry is simplified, is made interesting. Chemistry is the simplest subject you can offer. Do not run away from it. We'll meet again in our next video, and that will be on organic chemistry. Thank you.